8.1.4. The name of the game here is fluency. So we are going to continue working with greatest common factor, and we want to be fluent with it. We want to be able to look at a problem and kind of identify what we need to do and then do that with confidence. So I'm just going to take us through a bunch of practice problems here so that you can see it over and over again. And hopefully, as I'm explaining these things, you're leading me in kind of looking at the numbers and thinking about, oh yeah, what is next? He would have to do this next and some of those things, okay? So the first thing here is I'm going to be looking at 56 and 80. And I'm looking for the greatest common factor, the greatest common number that multiplies in both 56 and 80. And so there's different strategies we've been using. I'm going to look at this, and I can tell that my greatest common factor here is 8 based on just kind of what I know about my multiplication facts. However, if you're not sure how to get to that, you can always pick the smaller of the two numbers and list the factors. So I'm going to list the factors of 56, which are 1 times 56, 2 times 28, 3 doesn't work, 4 goes into 5 once with 1 left over, and then into 16 4 times. So 4 times 14. 5 doesn't work. 6 doesn't work. 7 works. 7 times 8. So here are all of my factors. And then I'm going to look at my largest one. So 56, I'm going to say, can this go into 80, or can 80 be divided by 56? And it cannot. Can 80 be divided by 28? It cannot. Can 80 be divided by 14? It cannot. Can 80 be divided by 8? And it can. 80 can be rewritten as 8 times 10. And then we have this x to the third, still multiplying. And then with 56, 56 is 7 times 8. I have that listed here for 56. So 56 is 8 times 7, and that's multiplying with x squared here. And they're being added in between. So I've broken 56 down into 8 times 7 and 80 down into 8 times 10. So my greatest common factor between my numbers is an 8. So I'm going to write an 8 down. I'll do that in purple. And then looking at my variables, I have an x squared and an x to the third. So the trick for this is we can always just take the smallest power of x. So I have x to the second. So that means I can take out an x to the second. I should have done that in purple. That's what I could take away from both of these groups that they have in common, is an 8x to the second. If I take away an 8 from my first group, I mean, I could just scratch it out here. If I take away this 8, I'm left with a 7. And then my x to the second, so I'm subtracting a 2 from both of my x values. That's where this x to the second, I'm taking away 2. So for my first one, x to the second minus 2, so 2 minus 2 is 0. So if I get 0, I'm just not going to have an x value here. In my second group, 8, scratching out 8, and 3 minus 2 makes 1. So I'm left with a positive 10x to the first. And now that's been factored out. Remember, greatest common factor is like reverse distributing. In number 2, I'm going to use the same sign that's in front. So my greatest common factor automatically has a negative. I'm going to look between 9 and 45. I have a greatest common factor of 9. So if I were to rewrite these, I could rewrite this as negative 9 times 1 times x, and this could be negative 9 times 5. So negative 9 is my greatest common factor. And now I'm left with a 1x plus 5. Because I took a negative away, both of these signs are going to change. So now it's positive, positive. Okay, between 12 and negative 6, my greatest common factor is 6. Again, if I were to list my smaller number factors, so out of 12 and 6, 6 is my smaller value. So I'd have 1 times 6, 2 times 3, and then I start with my 6, and I say, can 6 go into 12? Can 12 be divided by 6? And the answer is yes, it can. So 6 is my greatest common factor. So I'm going to rewrite 12 in terms of 6. So I'm going to say 6 times what makes 12? And then I'm going to rewrite my 6 here. 6 times 1. I have an n squared, and these are subtracting, so I'll put my minus sign here. So my common factor is 6, and I do not have common variables to take out. So I can only take out a number on this one, and this would leave me with, if I took out a 6, it would leave me with 2n squared minus 1. Now if you can do these in your head, that's great. I'm trying to give visual, a visual way of kind of seeing what we're doing in our heads if you're doing that step in your head. For this one, I have a negative in front, so I'm going to take out a negative. And my common factor between 7 and 14 is 7. So for this to become a negative 14, I would use a negative 7 times a positive 2, and then still have times x squared. For this to be a positive 7, if I'm using a negative 7, it would have to be a negative 7 times a negative 1. And so my common factor here is negative 7. So that's where I got that from. That's my common factor. And what I have left over is 2x squared and a negative 1. So this would say minus 1. So negative 7 times 2x squared minus 1. That's our answer. Between 12 and 15, I have a common factor of 3. Again, if I were to list my factors of 12, 1 times 12, 2 times 6, 3 times 5. Can 15 be divided by 12? No. Can it be divided by 6? No. Can it be divided by 5? No. Oh, sorry, for 12. I always do this. It's 3 and 4, not 3 and 5. Can it be divided by 4? No. Can it be divided by 3? Yes. So 3 times 4 makes 12. 3 times 5 makes 15. To make a negative 15, using a common factor that's a positive 3, means that I'm going to need a negative 5 here. So, and then I still have my r to the third. I don't have common variables because I only have r in one of my terms. So that means if I go through and I scratch out my common factor, I'm left with 4r to the third minus 5. All right, between negative 60 and negative 50. So we have a negative in front, so I'm going to factor out a negative. And our common number is going to be a 10. And we do have x values in common, so we are going to use the smallest one, which is x to the 6. So that's going to be our outside number. So now we just have to figure out what's left over. So if I am using a negative 10 here, I'm going to have to figure out what does that multiply with. And if I'm using a negative 10 here, I'm going to have to figure out what that multiplies with. And then I have x to the 7th. I'm going to try this a different way. I'm taking 6 out. So I'm going to subtract 6 from both of these. So let's see. Negative 10 times 6 would make negative 60, and negative 10 times 5 would make negative 50. So we're factoring out our negative 10, so I'm going to cross that out, and I'm left with 6. And then x to the 7 minus 6 makes 1. So I'm going to get x to the first. And then in my second one, I'm factoring out a negative 10. So I'm left with a positive 5. And then 6 minus 6 makes 0. So I'm not going to write my x in. So this is my answer. Here we have negative 40b plus 10. So my leading number is negative. So I'm going to pull a negative out. And between 40 and 10, my common factor is 10. And we do not have a b in common, so that we can't take a b out. So what are we left over with? Well, if I rewrite this in terms of a negative 10, to make negative 40, it would be negative 10 times 4. And to make a positive 10, it would have to be negative 10 times negative 1, would make a positive 10. So now I'm going to cross out my negative 10s, because those are my common factors. I still have a b, so we're saying 4b here and negative 1 here. In this one, our common factor is 4. So if I were to write this as 4 times 1 times n, and this would be 4 times negative 3 to make a negative 12. So 4 times negative 3 makes a negative 12. So my common factor is 4. I'm going to cross my 4's out, and I'm left with 1n minus 3. Okay, last 4. In this one, I have a leading coefficient. My leading coefficient is negative. And my common factor, my greatest common factor between 10 and 4 is 2. So I'm going to use a negative 2. These both have a's, which means that I can take an a to the first power out, because that's the most they have to give. So I'm going to take a negative 2 a to the first. So I'm going to rewrite negative 10 as negative 2 times positive 5 a to the third, and this is going to be negative 2 times negative 2 a, and I'm subtracting 1 from both of these. So this is a to the first minus 1. So now all I have to do is scratch out. Here I have a negative 2 and a negative 2. 3 minus 1 is 2, and 1 minus 1 is 0. So I'm left with 5 a to the second minus 2 a to the 0, but I don't need to write that in, so that's my answer here. All right, and then I'm just going to do this one last. We'll skip those other two. So between 35 and 56. So this is a nice large number, so I'm going to list my factors of 35. 1 times 35. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 works. 5 times 7. 6 doesn't work, and then 7, we're back. If I have 7, I've already listed it here, 7 times 5, so I'm not going to go backwards there. So now I'm going to see which one of these fits into 56. What can 56 be divided by? So can 56 be divided by 35? No. Can 56 be divided by 7? Yes. We could rewrite 56 as 7 times 8. times n, because it's multiplying with that n. For 35, we can rewrite 35 as 7 times 5 times n to the 4th. So my common number is 7. That's what I can take away. And my common variable is n to the 1st. So if I go through and I can get rid of my 7's, and I can subtract 1 from both of my n powers. So minus 1 is going to give me a 3 here, and minus 1 is going to give me a 0. So this one kind of goes away if it's 0. So now I'm left with 5n to the 3rd plus 8.